Hello friends, in this lecture we will cover the next type of flip-flop, that is D flip-flop. Now we will design our D flip-flop by using SR flip-flop. So to design D flip-flop by using SR flip-flop, the basic concepts of or the conclusion of SR flip-flop is very important. Now as per the truth table of our SR flip-flop, if both the conditions are 0, means when S equals to 0, R equals to 0, then our both the outputs, that is Q and Q bar, both will force to be equals to 1, means our flip-flop will be in rest condition. Similarly, second condition, when S equals to 0 and R equals to 1, then our Q equals to 0 and Q bar equals to 1, means our flip-flop will be in reset condition. Similarly, when S equals to 1 and R equals to 0, then our Q equals to 1 and Q bar equals to 0, means our flip-flop will be in set condition. And the last condition, when S equals to 1 and R equals to 1, then both the outputs, that is Q and Q bar, will be in no change condition. Now what is D flip-flop? Now D flip-flop has two inputs, that is D and clock. The D flip-flop has two outputs similar to our SR flip-flop, that is Q and Q bar. The Q output considered as the normal output and the other output, that is Q bar, is just a complement of output Q, similar to our SR flip-flop. Now let's design D flip-flop by using SR flip-flop. Now if you see the circuit, then our circuit is actually divided into two parts. First part is for inverter and second part is for our get SR flip-flop. Now why inverter is used? Because as per the truth table of our SR flip-flop, for these two conditions, now which conditions? When our S equals to 0 and R equals to 0, our flip-flop is in rest condition. Similarly, when our S equals to 1 and R equals to 1, then our outputs, that is Q and Q bar, are in no change condition. So to design our D flip-flop by using SR flip-flop, what is our objective? To avoid these two conditions. Which conditions? That is S equals to 0, R equals to 0 and S equals to 1, R equals to 1. So to avoid these two conditions, we require inverter. And second part of our circuit is simple, our SR flip-flop. Now as the input to our D flip-flop is only one, that is D in, and another input is clock. Now what is clock signal? Now to trigger or to turn on our D flip-flop, we require proper clock signal. Now in this circuit we will consider, that is we are using positive edge triggered clock. Now what is the difference between positive edge triggered and negative edge triggered clock? Now if suppose there is transition from 0 to 1, then this clock will be considered as an positive edge triggered. Similarly, if suppose there is transition from 1 to 0, then there will be our negative edge triggered clock. Now our positive edge triggered clock is indicated by 1 and negative edge triggered clock is indicated by 0. Now let's check, as the input to our D flip flop is only 1, that's why total number of two input condition as per our equation, that is 2 raised to n. Now here n equals to 1, so 2 raised to 1, which is equals to 2. So total number of two input conditions, that is our input will be equals to 0 or our input will be equals to 1. Now before going to check these two conditions, that is when D equals to 0 and D equals to 1, let's check if suppose clock equals to 0, because as I told you, we are using our positive edge triggered clock, means our clock should be equals to 1, then and then only our output will change, that is Q and Q bar. Now if suppose clock equals to 0, then what will happen? If suppose clock equals to 0, then our input will be in don't care conditions and our output, that is Q and Q bar, will be as it is, means they will be in no change condition. Now if suppose, now let's check condition, that is D in equals to 0. Now when D in equals to 0 and clock equals to 1, when D in equals to 0 and clock equals to 1, then our S equals to 0 and R equals to 1. Now why R equals to 1? It is due to the inverter. So input to the first NAND gate, that is NAND gate 1, R equals to 0 1, as S equals to 0 and clock equals to 1. So input to first NAND gate will be equals to 0 1. So output of first NAND gate will be equals to 1, because as per the truth table of our NAND gate, if any one input is low or 0, then output will be high. So output of first NAND gate, which is equals to 1. Similarly, the input to the second NAND gate, which is equals to 1 1. So the output of second NAND gate, which is equals to 0. Now let's check the output conditions of NAND gate 3 and NAND gate 4. As input to NAND gate 4, one input to our NAND gate 4, which is equals to 0, so output will be equals to 1. Because as per the truth table of our NAND gate, if any one input equals to 0, then output is compulsory to be high. So as the input to fourth NAND gate, one input to fourth NAND gate, which is equals to 0, that's why Q bar equals to 1. So as Q bar equals to 1 and it is cross coupled means output of fourth NAND gate is one input to our third NAND gate. Similarly, output of third NAND gate is one input to our fourth NAND gate. So as input to fourth NAND gate, one input to fourth NAND gate, which is equals to 0, so Q bar equals to 1. So as Q bar equals to 1, so both the inputs to the NAND gate 3, which is equals to 1, 1, that's why Q equals to 0. So what is our conclusion? So irrespective of present state, the next state, that is Q equals to 0 and Q bar will be equals to 1. Now this condition is also called as an reset condition. Means what is our conclusion for first case? When day in equals to 0, then our Q equals to 0 and Q bar equals to 1, means our flip-flop will be in reset condition. Now let's take second condition, that is when day in equals to 1. Now when day in equals to 1, then S equals to 1 and R equals to 0. Now why R equals to 0? Due to inverter. Now both the inputs to the first NAND gate, that is NAND gate 1, are equals to 1. So output of first NAND gate will be equals to 0 and output of second NAND gate will be equals to 1. Now let's check the output condition of the third NAND gate and fourth NAND gate. As one input to our third NAND gate, which is equals to 0, so output of third NAND gate will compulsory to be equals to 1. That is Q equals to 1. As Q equals to 1 and it is cross coupled, so both the inputs to the fourth NAND gate will be equals to 1. So Q bar equals to 0. So irrespective of present state, the next state, that is Q equals to 1 and Q bar equals to 0, and this condition is called as a set condition. Means when D in equals to 1, then our flip-flop will be in set condition. So what is our conclusion for D flip-flop? If D equals to 0, then our flip-flop will be in reset condition, and when D equals to 1, then our flip-flop will be in set condition. Thank you.